All right, so now we need to operate the software. I understand it's not very clear on the screen. So for the LCM operation, all these buttons you can play a little bit. So we have magnification, accelerator voltage. The accelerator voltage you have is good to choose in the beginning. You can change during session 2. So for example, if you're working on material which is possible charging, you want to start to from voltage a little bit low before you move up. So with time, you will know which voltage is best for your sample. Yeah, so to change the voltage, you can simply type a number or just select a number. Let's start from 5 kV today. So just simply click 5. The next thing is the spot size. So the spot size, we have a list here. If you see, we have 1 to 7. So the spot size, larger spot size, give you more electron beam. So you will have higher signal counts. But more electron beam, larger spot size, which means poor resolution. So you need a combination of signal counts to the resolution to get the best looking image. So normally we start from 3. So the next thing is the alignment. We have lens alignment. This is reduced area, and we have link button here, and we also have a number of buttons with arrow key under list. So this is automatic. If you click, it will automatically do. I normally only suggest user to do automatic contrast brightness. The other automatic operation need a good sample, uniform, for example, gold nanoparticle symbols. If your sample don't have a uniform feature for the software to do the calculation, then this alignment won't be as good as you do manually. Okay, so this is a contrast, also is called video scope to help you adjust contrast brightness of the image. We will play later. The next thing is the wear time pixel. Yeah, the wear time, if we think about how LCM works, so for the LCM, we actually shoot electron beam on the sample point by point. Okay, so at each point, the detector, we have different signal detect, for example, secondary electron beam detector, backscatter detector, because during the electron beam shoot on the sample, it will interact with the sample, give you different signal. It will give you different signal counts. So if you let the beam to stay at one point for a long time or shorter time, the time is called the wear time. So longer, you will get higher signal counts, but it also take longer time to scan the whole image. Also, if your sample is sensitive to the beam, you don't want very long the wear time there, so it will have to give you more damage. The next thing is pixel. Okay, it's called scanning resolution. Normally, I cannot click until I start the scan. Not until. So I just highlight the first photo so you will show. So if you click here, we have a number preset the screen pixel. Normally we use the second one or the third one. If you choose high pixel time, you see it will take longer time for you to scan through the whole window, the frame. Okay. The next thing is a camera, the snapshot. We use it sometimes. You can use F4 button sometimes, or you can also use F6, I guess. So you can also take photo. I show you what to do when we want to record image. It's the pause button, and here is the integration. So what's the meaning of integration? We have a line integration here and a frame integration here. So if your sample, if your image is noisy, you want some integration. Yeah, that's needed some play. So normally we use a line integration for do a lot of time for the sample which is a sensitive beam, we will use a frame integration because we just quickly scan a number of frames and put together to get average. Okay, that will have minimum damage to the sample. Yeah, here is a, I don't know why this is a measurement tool is disabled here. I need to play with it. All right. So on this side, we have some preset scanning speed for you. S1 is fastest, S6 is slowest. You can also change this by click the, for example, I click the S1 and then I can change this preset value. This sometimes is used for example, which is sensitive to beam. We will get some integration there based what we want. Okay, we will play when we have time. All right, so this is the software. On the right side, we have a list of buttons. In the first button, when we start, we see it has a vacuum interface, a column. This you can also set up a KV and spot size, and has a beam on button here. This we will come back, click on it. Have magnification, a beam, stigmator, and a beam shift. At start recession, it's good to check, make sure the beam shift is in the middle. If not, just right click on the mouse and select 0. The next is a stage BIOS. The beam deceleration is only useful when we sometimes we use it, but if you need it, if you think it's in need for your sample, this is useful when you cannot use a high voltage on your sample, but you still want a good signal. For example, sometimes you only want to use 2 kV, but 2 kV won't be able to create a good signal to the detector. Then you have to use a beam deceleration to apply a BIOS to the stage, so that it's kind of working like a lens to make your signal, like second electron, go to the detector. A backscatter electron go to, mostly is backscatter detector, go to the electrons go to the detector more easily. Then you still maintain that signal counts. And the scan rotation we will play during the session. Contrast practice you can play. All right, so the next is navigation. We have played earlier in this interface already. And here is a detector selection. So now we're using the custom detector, is a custom tool for the ABS. We normally leave the second screen to be CBS, so we can click CBS there. Okay, so you can have all, which means we will get all. It's kind of, if you look at this, it's a CBS is kind of circles. The detector is divided into A region, B, C, D region. Your signal count depends on which region you choose. Okay, it's a combination of all these selected ones. You will go to your detector and put in the image. For example, you can select A region only, a B region, a C region, right? Or you can customize it. I can click ABC, or we can select A and C. So this combination can give you different contrast of your sample in the image. So you give you some information about the geometry, maybe composition too. So yeah. So this is the detector. The left quarter detector normally we set up to be the EDT detector for the high vacuum mode. If we go to low vacuum mode, we will set up to be low vacuum detector. So pay a little bit attention to the detector at the start of your scanning to make sure it's what the detector you want. The next thing, this is basically just a Photoshop, mini Photoshop here. You will play, you will know. Sometimes you come here, you see the image is huge. So it's just because it's here, the digital zoom is on. So we go back to 1. So if you select the window, you will digital zoom it, okay? So don't be scared if you see something very different, the image become very big, or something not same as you last see. Come here to see whether you use a digital zoom there. The next thing is alignment. I don't need the user to do this type of alignment. So this is a kind of engineer or my alignment. If it's a change after something like that. Okay. So this is a preset. I don't need to come to here, and I don't need to come to alignment. So basically, you're playing these 3 buttons, or maybe a little bit of mini Photoshop here. All right, let's come back to the first button. We are ready. You see the chamber is fully green. We have selected right key by spot size for us. We're ready to turn on the beam. Click the beam on. So if we click the scan button, you will see some feature there. If you see all white, it just contrast brightly, it's not right. So if you need adjust contrast brightness, you have to highlight that window. So now, just now, I did not highlight the right window, so it did not do the contrast brightness. So I highlighted now, it will appear blue. Then you just click contrast brightness. You will see something come out. You know, we're using 5 kV. Should have something. Let's go to all. Go to 1 micron. I'm just wondering whether it's working. That's interesting. Anyway, we will come back to this detector again. I'm going to click the integration off. We work on this left quarter to see the second electron. It's called EDT detector, electron image. So to get the image, we have to find the right place. So this now, I don't know whether it's on the silicon wafer. I put on the sample, I put it on. I can drive around. To drive around, you can double click the place you click will move to the center. Okay. The image here, if you don't use image rotation, when you have image rotation or rotate, you will see an icon here. Or if you don't have stage rotation, the stage rotation is 0. So the image, what you see here is 180 degrees rotated. For example, now, if you look at this interface, this is silicon wafer, this side is silicon wafer, this side is a whole metal stuff. But if you look at it, it's reverse. So just put that in mind when you drive. So another way, so just now I show you, you double click the place of you click will move to the screen center. Another way to drive is click on the middle wheel of your mouse. So middle wheel of your mouse, when you click on it, you will see yellow circle there. So if you move the mouse to the direction, it will like you are driving. Now I'm trying to drive along the edge. So if the arrow is far away from the spot, the circle, then it will drive very fast. So if that's the case, you need to also make your dwell time short so that you can refresh the screen faster. So let's do it again. So we can drive along here, right? So if you want to drive slowly, we drive slowly. We keep it around so we can drive along. So this is another way to drive the sample. So I show you two ways. One is a double click. You will move to center. Another one is holding the wheel and move the mouse to the direction you're going. Okay. So now we find the area of interest. Okay, I'm interested on this particle side, not this blank side. So I just work on the interface. Okay, so I double click on this interface. Now we can change the magnification. So when you zoom in, so we have magnification button here, or you can select magnification. Normally, I will use the knob, okay, which is you have see here the magnification knob, the stigmator, an image, shift, and focus. So normally I would like to use the knobs rather than we do have soft key to do focus. For example, if you right click, you will actually do the focus. Move left and right, it will do the focus. But I prefer to do that. So let's say change magnification to higher. Okay, we use a focus knob. For the focus knob, we do have two knobs there, fun and cost. I would suggest never use a cost. It's very cost, really big step there. So we use a fun button, fun knob there. Okay, so for example, what you see here, I see a particle. If I move to the screen center, if I zoom in, you see it's kind of blurred out. This is out of focus. To bring it focus, we adjust focus now. Okay, you will see it become cleaner and cleaner. You will see some morphology there. Okay, this is the focus. I'm going to zoom in a little bit more so you can see better. It's a good example here. I also suggest use reduce area, which is we just scan this small region on the sample. Okay, so now what do I adjust? I bring sample to focus. Okay, this is focus. Okay, we leave it there. We come back to here again. So after you bring to focus, I also suggest user to use a link function. It's useful, especially you want to fix walking distance, which is consistent for if you want to do publication. Normally we use WD a 10 for this instrument. Now, if you look at the walking distance here, is 12.5. And what's the meaning of walking distance? Is you know, for the LCM, we need to shoot the electron beam on the sample surface. We have to focus electron beam to a point. How good the point it is affect your resolution. So that focus distance from lens to the point is the focus. So that point is on your sample, then your sample will be in focus. So, okay, so now we adjust the focus and we know, okay, the length to my sample surface is 12.5 millimeter. My sample is in focus. We are going to test the software. This is called link. So we test software, my sample in focus at 12.5. Now, just click the link button, okay? So you can only click the link button only when your image is in focus already. Okay. After that, after you click that, you will notice the Z on here, the Z button here. Earlier was a red arrow point up. Now it's a gray arrow point down. It's consistent with your walking distance here. So which means now my Z is not the stage position, is actually is a distance between my lens to the focus point. So we know the sample was focused earlier. We want to change the walking distance to 10. So just simply type 10 here. Okay. So now if you look After I type 10, if you pay attention to here, if we can keep this on. So this is my sample location. If you click 10 and click enter, you will see the sample will move up. And your location still maintained should be similar. The magnification is actually 10. I don't know when I 10, but it's okay. So your sample, your target should be still around that place. I need to do some alignment on this microscope. Okay. So we bring this back, okay? So now you know the sample is around focus at walking distance 10. Now we're going to fine tune the focus. We use a reduce area box. We can zoom in a little bit. If your target is out of this green box, you can move the box. Just put the mouse on the edge of the box, not inside. Okay, on the edge of the box, you will see arrow cross. So then you can move the window to the place you like. Okay, then you adjust the focus knob to make image focus. Let me zoom in a little bit there. Okay. If you look at this particle here, and okay, you can see. So when I adjust focus knob, it becomes blurry and clear. It's pretty much in focus. It's good. And if I turn more, it will become elongated and to the vertical, to this direction, right? So let's take it back. This is called stigmatism. So we turn the knob back so that to bring to focus. If I turn the knob more, it will elongate it around this direction, which is about 90 degrees from the earlier elongation. So we turn it back to the place which is no elongation. The image may not be clear, but no elongation. So this is the place you should stay. This is the focus place. The next thing is adjust stigmatism. We have two stigmator buttons, which is on this controller box. So stigmate them X and Y. Okay, we're going to adjust X and Y to make image sharp. Okay, so now adjust X. You will see it become blurry. I turn back, blurry. I stop at the best place as I can. And the same for Y. We turn and until it's good. So this is how we adjust stigmatism, especially when you see the image become elongated or stretching, which normally indicating the stigmatism. So yeah, we can, yeah. All right, so the next thing is a lens alignment, okay? We have automatic lens alignment or lens alignment here. So normally, again, I only suggest user to use automatic when you have uniform sample. Normally, manually will do better. And I noticed this microscope is very stable. So once you adjust it, it should be good for a long time. So the user normally don't need to worry about too much. Okay, so let me try to see how far is, because I haven't used this microscope and adjust it for a long time, so I don't know how it's performing. Let's see how far it goes this time. So simply click this button. You will see, oh, that's a lot of. So you will see the image or the particles jumping up and down, sometimes left and right, sometimes diagonal. So when you see this type of movement, you can also see this target, the green target here. So you just simply move. If it's up and down, you move the target up and down, and this will make the jumping less. If it's the target, if your particle is out of the window, you just simply move the window down to check it, okay? So now you will see it's mostly left and right, okay? If you want it still in the center, double click, this particle will come back to the center of the screen. So now you will see it's mostly left and right. We are going to move left and right of this target to stabilize it. So it's much better now. Yeah, you can either double click the particle to move to the back to screen center, or you can just simply move your window to there. So it's much better. We can fine tune a little bit. Okay, what you see the image become focused and blurry. Focus and blurry. The shaking is minimum. Which is around here. After this, we click this wobbling off. We will need to adjust the focus a little bit, okay? And then we adjust stigmatism again to make the image as sharp as possible. Okay, this is good. We can check the wobbling again. You'll see it's almost staying there, no jumping. Okay, this is good enough for this purpose at the moment. Yeah, so this is a alignment to help you to get a clear image. Sometimes there's some trick here. Okay, for example, when you do wobbling, you cannot let the dwell time too slow. If too slow, the wobbling will be too slow. For example, if I put 10 seconds, you're jumping, you cannot be able to see. So use the appropriate dwell time for your alignment. Okay. Normally nanoseconds, it depends on your pixel too. So you can adjust that before you really start to tune to make sure you can see a live changing image. Okay, this is alignment. All right. Okay, now we can see our feature pretty clear. This is a gold film. Okay, we can zoom in, we can move around. Okay, so you like this region. So now if we like to record the image, we change the magnification we like. For example, we like to go to 50,000 or go to 100,000. You just change the magnification. Normally, I suggest user to focus, do the alignment, make it great at high magnification. For example, you're going to take 50,000. I would like you to go to 100,000 magnification at least to do the focus to make it best. Okay. If not, you will get the best image. Okay. After you adjusted the focus at high magnification, it should be in focus in low magnification. You can see it, right? So now we drop down to 100 or 50. It should be very clear. Okay, you will not be able to see much difference on the small screen. So the next thing, the detectors. A lot of time I suggest user to use both detector to get an image because it will get you even unless you think it's one detector is not really necessary. So yeah, if we want the CPS detector to be on, let's see the contrast brightness. Let's see whether it can automatically adjust. It still cannot. Okay. So if you cannot automatically adjust, I still would like to see whether we can make it. Okay. So you can use a video scope, which I click here. If I click this screen, you will see the video scope there. You will see some noise. Kind of. This is a kind of it gives you a line scan update of the signal comes when you scan across, so it's changing. So so to make it good contrast brightness, we normally make this noise to be around this yellow line, up and lower yellow line in between, and the brightness in around the between the middle line. So this is how we adjust. So you will get a much better looking image. And the same, if you want to adjust this size, this one, you have to highlight it to make it blue. So now it's overwhelmed to me, it's too bright, okay? Okay, if you have something, so, so it's very difficult. Why? Because we only use 5 kV. 5 kV3 should give you very good signal counts. I don't know why. It's supposed to give us very good signal count. It's not good enough in my view. It's not. It's very bad. Okay, so I will see what's problem with this detector. Okay, so now after you adjust this kind of a thing, it's ready to very small window. Okay, yeah. Another thing is if you, for this system, if you use a shift key, you will automatically apply the option you choose to all the windows. So for example, now if I hold the shift key on the keyboard and click the video scope, both of them will disappear. If I want both of them on, do it will do the same. Okay. So all right. So this is how we fine-tune an image. If your sample is sensitive, you normally move away from the place you're interested and get this type of focus adjusted, then come back. How to do that? We have a arrow key, which is on the keyboard, right? So what you need to do, you just need to click this arrow key. If you remember, you click the right key in the beginning, then we just click the left key. The window should come back. All right, this is about the how to make image clear. So next thing, we need to recording. So to do the recording, we need to choose the right right pixel, right integration to make image clear. So normally we try to see which one is best for the sample. So for example, now I changed the wait time to the 3 microseconds. The left image becomes much better. We can also put integration there. We can put 4 there if we like. You will see much better. And you can also check the video scope to make sure everything is still, let's ignore the right image at the moment. So if you do that, maybe we can change this a little bit higher because we are not focused on this particle. So if we look at the film, I want to make this higher, 6 counts, okay? This will look much better to me. I increase. Again, if your sample is sensitive, you try to avoid this region. You do adjustment nearby and then come back. Okay. So, all right. So after you did all this, I suggest use a pause button rather than use a photo button. The photo button is a preset scanning speed wait time for you. So maybe that's not the option you like. So if you choose the right option, just simply click the pause button. If you need to freeze both images, you use a shift and pause. Okay. So now if I like only the left image, I just highlight the left image and click pause. And you will have a button there and blinking. And you can see the scanning line. So after you finish scanning, we will go to record. If you like the second image, just highlight and pause. Okay, or you can use the shift key and pause both images. So after you finish the whole window, whole frame scanning, you will stop blinking, and then you can go to File, go to Save All, or if you only have one image, just save as. But make sure you highlight the image you want to save. Okay, make it the blue. So if you want to save all, just click Save All. So all right. So when you save all, this is also good for you to have a preview. You put a mouse on the image, it will show you. I think it's a new feature. It's a recent update. So you need to set up the file name. Select this dot, click go to Data, and put your name. Select New Folder, put your name there. This is training. I put training. Okay. And then you highlight it. Oh, we have a training here. Okay, we just use a new folder too. Okay, then we open it. Okay, normally I suggest user to set up sub folder for each day. For example, today is September 15th, 2020. You put there. Okay, then you put your sample ID, sample 1 or sample something. You put your name you like, sample 1. Okay, you type it, and you say, okay, the left image we're changing now is a EDT detector. So you put EDT there. Okay, and then you just save the TIF. So the format, I suggest at least use a TIF 16 bits. The best use a TIF 24 bits. Yeah, it's now the computer, the hard drive is large. It's no need to save into smaller file. Okay, okay. After you set up this file name, if you want the second image, okay, you can copy this file name to the second line. Just Ctrl+C, Ctrl+V, but don't forget to change the detector. Okay, use the same location, just a detector difference. So this is CBS. So I put the CBS there. The next thing is you really make sure you check the data bar. If there are no data bar, you will not be able to see this information. Okay, even though it will be with your data, you will not be able to see on the image. Okay, so it really depends. Some people don't like it. You can say both. Yeah. All right. The next thing is overlaid objects. If you happen to use annotation, you maybe use overlaid graph to have this annotations on the image. Otherwise, you don't use it. Okay. Then you just select save. So this is how we record image and save into files. Okay. We can normally, I suggest user to record a number of images after. Yeah, so I click the pause button off, click integration off, change scanning speed back to fast. Now I want to change the magnification to 10,000 or maybe 500. So I just need change magnification, and we can just take an image. I change this back to maybe 5 microseconds. I use one integration, 2 integration. So if I like it, I just click the pause button. You can also adjust contrast by at least a little bit to make it what you like. Okay. Okay, we can shift and pause. Yeah, pause both images. And then you go to File, Save All. You will automatically add a 001 lower dash 001 to the file name. The next image we record more will 02, so it will be automatic. You don't need to worry. You click Save. Okay, I can pause off. So now we are done with this sample. We can go to next sample. Just watch out if you happen to have a different height of sample. You need really, I would suggest user to use the same height. similar height, the difference best is less than 1 millimeter difference. For this sample, we see here we have a little bit clip. The clip screw is a little bit higher. When we dry, we still need to be careful. Because it's 10 millimeter away from the lens, we don't have worry here. But if you happen to dry to very close, you need to make sure you move down the stage before you dry horizontally. Okay. So all right. So today we don't have issue here. So we just simply click or drag this mark the cross to the next sample. So I'm going to double click. So you will move to the clip, where the copper clip it is. Let's zoom out. So this is just too fast. So just highlight the screen, you will change just too slow. So now we want the fast scanning. We change the magnification to low. You see the clip here. Okay, we are pretty much close to the place. A little bit off. Okay, we are in the corner on this image, but this is a little bit off. Okay, so yeah, so we try the place we like. Okay, any place. We just zoom in and bring to focus again. That's very ridiculous. We need to compare this. It's supposed to adjust a little bit, but not too much. The magnification. So what I see here is when we change the magnification, when change the focus, the magnification change too much. Okay, it's not supposed to behave in that way. Yeah, it will change a little bit. So now we found a target. We bring this to focus. So normally it's good to have some dust particle or some feature to have you to bring sample to focus. So we are not interested in the dust particle. We're interested in the morphology of this one. So, okay, we'll see this type of feature here. So the next thing is, you see the walking distance drift a little bit again. What we can do, we can right click on this linking button and select unlink. Okay, so that will remove the previous relationship, because that is some previous sample. Your sample maybe has different height, or the holder has a different height. So if you want to keep this walking distance to 10, you unlink it and link it again. Okay, after make sure it's focused, we link again. We just simply type 10 there. Okay, then you enter. All right, so we still keep it at 10 and then you focus. If you want to double check the alignment, that's also good. Okay, if you don't want change to be very close, that's also okay. But if you are trying to do very high resolution image, it's good to check the alignment, which include the wobbling. Yeah, it's very good, right? Very a little bit up, but it's very close. It's acceptable. And also the stick material, this is the place you want to change. And again, it's also good practice to make sure the beam shift is zeroed. Sometimes we do use a beam shift, and when we go to very high magnification, we just use the beam shift to move the sample or the place to the center of the screen, or to the place we like to take an image or something. We do use image shift. So if I drag it, you will notice, right? It can move. All right. So if you use that, click 0 button to neutralize it. All right. So yeah, you can record the photo after you change. All right. Okay, if we like it, we just pause it, or you can adjust contrast brightness to the amount you like. So after the pause button stop blinking, we just go to save. Okay, select save all. Now we just need to change this. It's a sample 2 if we like, and you can change this to 001 if you like. If you don't change, that's also work, or you can delete that one. So just save it. All right. So this is how we play. And if you want to change the voltage, yeah, you can change now. For example, I change the voltage to 10 kV. Higher voltage normally give you better resolution, but more damage to the sample. Also, yeah, the higher resolution is come from two parts. You can focus the beam better at higher voltage. That's one thing. The second thing, your signal count is higher. So after you change voltage, it's normally good to check alignment to make sure it's still good. We adjust focus. Okay, this focus is just stigmatism. Make image sharp, and we check the wobbling. It's a little bit off. So, yeah, left and right, you just move left and right. So you move the tag, it depends how the image shape. Yeah, you cannot make it really ideally perfect, you know. So, but when it's around that place, it will be good enough. Everyone has a certain different judgment. So you put to the best place based on your own judgment. This is good enough anyway. Yeah. So after that, you just focus and stick may hit them a little bit more again. Okay. After satisfied, just click this window off. You will see this sample has some beam contamination. Well, this is it will be well the beam contamination is not avoidable sometimes. So if you don't like it, you just move away from that place. So, all right, after we adjust it, we need to adjust this contrast brightness. It's too low in brightness. So we put around here, we put yeah. So the total signal count is too low, so that's why it's difficult to adjust. So we select the pause button if we like, or we can put integration there and pause it. Okay, then we go to File, Save All. Okay, so this is how we get the image. That's all for the getting image part. So if you're done with your sample, we need to go to shutdown and take out your sample. Click beam on button off. Okay, after it's off, click vent button. go to vent. Yeah, we don't have time to try low vacuum mode. We'll try next time. It takes about 3 minutes to vent. So that process will be the same as the beginning. When we load the sample, we wait. So while waiting, I show you how to do the data transfer. So your data is saved in the main PC. We are not allowed user, no option for you to save there, to do the transfer directly to the main PC. So to transfer your data, we need to move your data to the support PC, which is on this one. So first we find your data. So if you click the Windows key, you will see the folder here. You just go to folder. When you click it, a lot of time you will jump to the right screen. So it's here now. Okay. So you go to data and find new folder. This is a folder I took today. And yeah, if you're the first time user, so it's good to just copy your name, the whole folder, just copy, and then go to transport destination. Okay, and this is share data on this computer. Just right click and paste. Okay, so it's here. So now you can use USB, or you can upload your worship box using this computer. I noticed the internet is not running right at the moment. I don't know why. There are a number of issues with this instrument, which I need to get it solved. All right. So if we now look at the venting, which is about half now. So we wait about another minute, then we can take out the sample. Almost there. All right. So that's what we need to do. So we just need cool here. The venting ready. We put this door slightly open. Gently, not too fast. All right. So just pour the sample out. Here. Yeah. Put the sample in safe place. Then we close the door. Okay. So after the door closed, we can come back to the software. And click pump button. Make sure high vacuum is selected before you click pump button. Select no accessory. And put the door in the middle of the sample room. See the noise of the start pumping already. So we wait a minute, then you can log off your QR code, then enter the session.